We're on page 11 of the chapter 14 packet, and we'll be discussing the half angle formulas. There's 3 half angle formulas, one for sine, one for tangent, and one for cosine. For sine and cosine, you'll notice that there's a positive or a negative version to the answer. You want to pick the appropriate sign based off of where the half angle lies. So that's an important note I'd like you to start off by highlighting. So you're only going to either pick the positive answer or the negative answer depending on where your half angle lies. So half angle formulas are used to, for example, find the exact value of sine of 15 degrees. Even though 15 doesn't fall on one of the unit circle angle measures that we know of, we would be able to find 15 degrees because that's half of 30 degrees, which we do have information on. So when we're finding the sine and cosine of using half angle measures, we want to make sure we pick the appropriate positive or negative depending on where the half angle lies. So when I'm trying to find sine of 15 degrees, I want to make sure I pick the positive version of the formula because 15 degrees lies in the first quadrant. So I'm going to take the formula that I see above and specifically positive because this is quadrant 1. 15 degrees falls in quadrant 1. And then I have square root of 1 minus cosine of a all over 2. And let's go back and figure out what do I plug in for a. So one of the biggest mistakes I see students making is plugging in 15 degrees there. Keep in mind that when you're looking at 15 degrees is your half angle. So when I'm plugging in the formula on the right hand side, I'm using what I know about twice the half angle, which in this case, if you're solving for a, would be 30 degrees. And it would make sense that I'm plugging in 30 degrees because that's what I do have information on, so that I can solve for something like sine of 15 degrees and 15 degrees being something that I don't have information on. So when I simplify that further, I get cosine of 30 degrees is radical 3 over 2. So the half angle formulas also come with it all these algebraic simplifications that we have to keep in mind. We don't want complex fractions where we have fractions within a fraction. So our problem right now is this over 2. So what we'll do is multiply, we'll ignore the larger square root and multiply the top of that fraction by 2 and the bottom of this fraction by 2. So if I were to distribute 2, I end up with an answer that is square root of 2 minus radical 3 all over 4. If I wanted to take that one step further, I noticed that the bottom is a perfect square. So I can split the square root and say that my answer is square root of 2 minus rad 3 all over square root of 4 is 2. And that would be my simplest answer. So for tangent of 75, we want to think of, well, if 75 degrees is not a familiar angle, but if I double 75 degrees to get 150 is. So a over 2 on this side is 75 degrees. Is a being 150 degrees helpful for me to use to find tangent of 75? And yes, it is. So again, with the double and half angle formulas, you want to kind of think of it as opposite. We're going to use the half angle formula because 75 is half of 150, and 150 is the value that we have the most information on, and that's going to be the value that we plug in on the right. So we go to tangent, and tangent has 2 different formulas, and it doesn't matter which one you pick, and neither one is easier than the other one. So you pick one to use, and let's say you picked the minus version. So 1 minus cosine of a, which is 150 degrees, all over sine of a, so sine of 150 degrees. So cosine of 150 degrees, with 30 degrees being the reference angle in the second quadrant, we have negative root 3 over 2, all over sine of 150 degrees, 30 degrees being the reference angle in the second quadrant. we have positive 1/2. So once again, we're left with a fraction, a complex fraction, a fraction within a fraction. So on the top and bottom, we can eliminate those fractions by multiplying and distributing 2 to the top and 2 to the bottom. So if we go ahead and do that, we end up with 2 plus radical 3. The 2's cancel out on the second fraction in the binomial. 1/2 times 2 is just 1. So our answer is 2 plus radical 3.